Lesson: Monitoring and updating deployed AI models. Monitoring and updating deployed AI models is a critical component of AI model lifecycle management. As AI systems become increasingly integrated into business processes, ensuring their continued accuracy, fairness, and efficiency is essential. These models operate in dynamic environments where data distributions can shift over time, potentially degrading the model's performance. Therefore, a robust framework for monitoring and updating AI models is imperative for maintaining their effectiveness. To effectively monitor deployed AI models, one must first establish a baseline for performance metrics. These metrics typically include accuracy, precision, recall, F1 score, and area under the curve for classification tasks. For regression tasks, metrics such as mean squared error and mean absolute error are more appropriate. Once these baselines are set during the validation phase, they serve as benchmarks against which real-world model performance is continually compared. A variety of tools and frameworks can assist in monitoring AI models. Prominent among these is TensorFlow Extended, a production-ready machine learning platform that provides components for model training, validation, and serving. TFX includes a feature called TensorFlow Model Analysis, which enables scalable and efficient model evaluation across large datasets. This tool helps in detecting drifts in model performance over time by comparing current performance metrics against established baselines. Another practical tool is MLflow, an open-source platform for managing the end-to-end machine learning lifecycle. MLflow facilitates tracking experiments to record and compare parameters and results, packaging ML code to reproduce runs, and managing and deploying models. By leveraging MLflow, data scientists can easily monitor model performance and retrain models when performance metrics fall below predefined thresholds. Model drift detection is an integral part of the monitoring process. Drift can occur due to changes in data distribution or the evolution of the underlying system. Concept drift, for example, happens when the statistical properties of the target variable change over time, which may lead to suboptimal model predictions. Tools like Alibi Detect, an open-source Python library, provide functionalities to detect various types of drift using statistical tests and machine learning algorithms. An example of concept drift can be seen in the financial services industry, where credit scoring models may experience drift due to changes in economic conditions or consumer behavior. A case study involving a leading financial institution revealed that their credit risk model's performance decreased by 15% over 6 months due to drift. By implementing a monitoring system with regular recalibration, the institution improved model accuracy and reduced default rates by 10%. Once drift is detected, the next step is to update the model. This process often involves retraining the model using the latest data that reflects the current environment. Automated retraining pipelines can be set up using tools such as Apache Airflow or Kubeflow pipelines, which enable scheduling and orchestrating complex workflows. These tools allow for seamless integration of data ingestion, pre-processing, model training, and validation steps, ensuring that models remain up to date. Updating models also presents an opportunity to incorporate new features that may enhance model performance. Feature engineering is a crucial step in the machine learning workflow, and iterative updates allow for the inclusion of additional data sources or derived features that were not available during the initial model training. Feature stores, such as Feast, provide a centralized repository for storing and serving features to models in production, streamlining the feature engineering process and ensuring consistency across training and inference stages. In addition to retraining models, it is essential to conduct a thorough evaluation to ensure that updated models meet performance expectations and do not introduce biases. Bias in AI models can lead to unfair or discriminatory outcomes, particularly when models are used in high-stakes decision-making contexts like hiring or criminal justice. Fairness-aware machine learning frameworks, such as FairLearn, help practitioners assess and mitigate biases in models by providing tools for measuring disparities and implementing bias mitigation algorithms. A real-world example of the importance of fairness in model updates can be found in a study conducted by a healthcare organization. the organization used an AI model to prioritize patients for care management programs. However, upon reevaluation, it was discovered that the model disproportionately allocated resources to certain demographic groups, perpetuating existing disparities. By applying fairness-aware techniques, the organization redesigned the model to ensure equitable treatment across patient populations, improving health outcomes and patient satisfaction. Continuous monitoring and updating of AI models also require a comprehensive logging and alerting system. Logging allows for tracking model inputs, predictions, and decisions, which is crucial for auditing and debugging purposes. Tools like ElkStack or Grafana offer powerful capabilities for aggregating, visualizing, and alerting on log data. Alerts can be configured to notify teams when model performance degrades or when unusual patterns are detected, prompting immediate investigation and remediation. Finally, fostering a culture of collaboration and communication among cross-functional teams is vital for effective model maintenance. Data scientists, engineers, domain experts, and stakeholders must work together to interpret monitoring results, identify potential issues, and implement corrective actions. Regular meetings and reporting mechanisms should be established to ensure alignment and accountability across the organization. In conclusion, monitoring and updating deployed AI models is a multifaceted task that requires a combination of tools, strategies, and collaboration. By leveraging technologies such as TensorFlow Extended, MLflow, Alibi Detect, and Fairlearn, practitioners can establish robust monitoring frameworks, detect and address model drift, ensure fairness, and maintain model performance over time. Real-world examples and case studies underscore the importance of these practices in achieving successful AI deployments. As AI continues to evolve, staying vigilant and adaptable in monitoring and updating models will remain a cornerstone of responsible and effective AI systems.